Hello, this is Team 6, and we're doing analysis and redesign of a hitch-mounted bike rack. Our team members include myself, Calvin, Hannah, Joseph, Stephen, Jacob, and Cody. Product overview. A hitch-mounted bike rack allows users to transport their bikes using the existing tow hitch on their car. We will be analyzing the 4-bike hitch rack shown in the photos. This bike rack can carry up to 4 bikes and can easily unpin and fold down so users can access their trunk space. This slide illustrates the exploded view of the hitch rack and all the necessary components needed to assemble the product. The parts listed and annotated show all the custom parts needed to manufacture the bike hitch rack, with the exception of 2 pins that are commercial off-the-shelf components. On this slide, we illustrate the entire assembly of the bike hitch rack and list all the parts including fasteners. There are 24 unique parts to this assembly, and through our redesign, we will attempt to reduce the overall part count and manufacturing costs associated with this product.
Through our functional analysis, the primary function identified for the bike rack is to transport a bicycle. The sub-functions are to secure the bicycle, attach to the hitch, assure dependability, assure convenience, enhance the product, and please senses. From these, numerous basic functions were identified, as can be seen in the FAST diagram displayed here. These basic functions are explained further in a future slide.
We identified 2 different assembly sequences for the bike rack. Sequence A begins with the bike holder tube and attaches the necessary smaller parts to secure the bicycles. Then it moves on to attaching the tubes and connections that attach to the hitch of the car. Sequence B first starts by attaching the tubes and connections that attach to the car, then moves on to attach the bike holder tubes and necessary smaller parts that secure the bicycle after. We then analyzed the assembly sequences based on these criteria. Sequence A proved better for transferring and handling, as it starts with smaller parts rather than the larger, bulkier parts. Sequence A was also better for fastening and joining, as attaching the smaller parts first ensures that the rest of the bike rack will not hinder the fastening of these parts. Ease of locating parts, ease of testing subassemblies, and ease of assembling in parallel were all the same for both sequences. Overall, Sequence A was better when judging based on these criteria.
The function component mapping matrix is displayed here, where the functions are the basic functions mentioned previously. Note that this matrix reveals 4 functions that must be fulfilled by all components. Withstand precipitation, withstand 100 miles per hour, which is assumed to be a general maximum speed for the vehicle, blend with the color of the vehicle, and lift by hand. In addition, this matrix reveals that the major structural supports of the bike rack, namely the hitch base, the center support, the elbow support, and the bike holder tube, must be designed and manufactured to meet a high number of basic functions.
On this slide, the bill of materials is shown, with each part listed with the associated quantity, material, and manufacturing and assembly processes. Preliminary costs were estimated by using bulk order fastener catalogs, lecture learnings, and prior industry experience to evaluate material and processes, summing to a total of $51.26 per bike rack. The BOM shows that the larger complex parts and assemblies, the unique fasteners and pins, and the functional need for corrosion resistance largely contribute to the overall cost. By evaluating the function component mapping matrix and the BOM, our team identified possible redesigns that could result in a reduction of product cost with minimal impact to critical product functions. Each of the 4 W plates are almost identical, so we can reduce manufacturing costs with no impact to the product function by commonizing each of these, and the same can be done with the 2 unique pins. The 2 different tubes separated at the elbow and vertical sections could also be consolidated into one part, and by keeping the interface to the hitch base the same, the functionality of dropping the rack to open the tailgate remains intact. Finally, redesigning the bike mounts into simple Velcro straps would eliminate numerous parts in each of the metal plates, plastic half pipes, and hand knob bolts. By referring to the DfMA quad chart, we recognize that each of the aforementioned components has a high functional importance associated with it, but have potential for redesign with their respective high manufacturing costs.
We identified 2 groups of customers for this product. The primary customers are recreational bikers and families who need to be able to transport 3 to 4 bikes of varying sizes. Ease of use and structural integrity are their priorities. The secondary customers are frequent mountain bikers and road bikers who only need to transport 1 to 2 bikes. They prefer a structurally sound bike rack that makes mounting and dismounting quick and easy. The majority of the product functions are the same for both customer groups. The only one that we see as different is rack capacity. The primary customers need to be able to transport 3 to 4 bikes, while the secondary customers only need to be able to transport 1 to 2.
This slide illustrates the differences between our product variants based on our primary and secondary customers, as well as our product classification that Hannah just described. Very clearly, you can observe that one is capable of transporting up to 2 bikes, while the other is capable of transporting up to 4 bikes. Now that the team has the product variants established, we intend to focus on how the assembly sequence is affected by having 2 variants. To do so, we have identified modules and platforms, as you can see here. The modules in blue will not be included in the second variant, so this means that variant 2 will actually have a shorter and simpler assembly sequence compared to variant 1. When looking at the common components, or platforms, shown in red, the team has discussed and concluded this is where the majority of the design for manufacturing and assembly improvement opportunity is. Specifically, there may be opportunities to simplify the design and to carry over common components to both variants. We will explore this and present our findings in our final presentation.